Hello everyone and welcome to Education Foundation. In today's video, we'll be looking at Introduction to Thermodynamics. In this video, we'll be covering the following: definition of thermodynamics, the branches of thermodynamics, the study approaches to thermodynamics, the applications of thermodynamics, and mechanics versus thermodynamics. So let's dive right in. So get your pen and paper ready so that we can dive right into the video. Definition of thermodynamics. The word thermodynamics is derived from two Greek words, thermia meaning heat and dynamis meaning force. So from these two Greek words, we can simply say that thermodynamics is the action of the force of heat. Or, to have a more concise definition, we can say that it can be defined as the branch of physics and engineering science that deals with how properties of matter are affected by change in temperature. So now that we know the definition of thermodynamics, let's move over to the branches of thermodynamics. Branches of thermodynamics. Thermodynamics can be divided into the following branches. We have engineering thermodynamics, chemical thermodynamics, and physical thermodynamics. But in this series, we'll be focusing on mainly engineering thermodynamics. If you really see thermodynamics in this series, we are focusing more on engineering thermodynamics. But let's broaden our mindset on the definition of the following branch of thermodynamics. Engineering thermodynamics. Engineering thermodynamics can be defined as the study of the relationship between heat, work, energy, and the properties of fluids. In engineering thermodynamics, we are mainly concerned with the term called fluids because this in engineering thermodynamics, we are mainly concerned with this term called fluid because the term called fluids actually mainly deals with liquid and gas. So we're talking about this in the subsequent part of our videos, what fluids are and other parts of matter are. But the engineering thermodynamics actually deals with fluids which do not chemically react with each other. It is a branch of thermodynamics that is essentially involved in studying problems relating to the most efficient way of converting heat to mechanical energy, that's heat energy to mechanical energy, and then mechanical energy to heat energy, or we can just say vice versa, as they'll call it. So that is why we say that engineering thermodynamics is the study of the relationship between heat, work, and energy, and the properties of fluids. Then chemical thermodynamics is the branch of thermodynamics that deals with the energy changes and equilibrium conditions in chemical reactions. That's just it for chemical thermodynamics. Then now we have physical thermodynamics, which focuses on the fundamental principles of thermodynamics as they apply to physical processes such as phase transitions, heat transfer, and behavior of gases, liquids, and solids. It is mainly used to understand properties or physical properties such as temperature, pressure, and volume in different states of matter. That's just about it for physical thermodynamics. So now that we are done with the branches of thermodynamics, let's look at the study approach to thermodynamics. Thermodynamics can simply be studied using the following approach. It can either be studied using the classical or postulatory approach or the statistical approach. So let's look at each of the approaches that can be used in studying thermodynamics. Number one, we have the classical approach to studying thermodynamics. We should take note of this definition, it's very important. This is the approach that deals with the gross or overall behavior of matter. It does not consider models of the structure at the atomic or subatomic levels, but rather is concerned to observe the physical progression of matter using certain postulates. So that's just about it for classical approach to studying thermodynamics. It's very important to actually take note of these definitions as they will help you to easily understand it without having to. It's just very important to take note of this definition. It will just help you. Then we have the statistical approach to studying thermodynamics. This is the microscopic approach. Remember, for the classical approach to studying thermodynamics was the macroscopic approach, but this is now the microscopic approach, whose objective is to classify the average behavior of the particles of matter using the theory of statistics. That's one. The objective is to classify the average behavior of particles of matter using statistics. That's one point. And then relate this macroscopic observed behavior of the matter. That means we have to relate this macroscopic observed behavior of the matter. So now that we are done with the approaches to studying thermodynamics, let's look at mechanics versus thermodynamics.
Mechanics is the study of the action of force on matter or a material system.
On the other hand, thermodynamics is also the study of the force of action on matter. But here the difference is that the force here is being generated by heat. That's one point. Let's look at the second point. In mechanics, force can be resolved and their effects can be determined in specific directions. Just like resolution of force, you see that the force has a particular direction to which it's going to. But in thermodynamics, it's not the case because here the force is heat, and heat is a scalar quantity that you cannot really see, but it can is actually heat is a scalar quantity, so it doesn't have a direction. But and in this case, the force here is heat, as I said earlier. In thermodynamics, heat has the capacity of changing the properties of a body. That means the properties of the body here I'm talking about is the volume, temperature, pressure, and energy levels of the body. It's also capable of changing the state of matter from one phase to another. That means it can change the state of matter from the solid to liquid state, from the solid to gas state, from the liquid to solid, from the liquid to gas state, and so on. Engineering thermodynamics can be applied in the following areas. Number one, in the generation of electricity. Number two, in engines for driving automobiles. Number three, in refrigeration and air conditioning. Number four, in mechanical and aerospace engineering. And then number five, in refinery to refine crude oil. So these are the applications of thermodynamics.
We have come to the end of this video. If you found this kind of content helpful, don't forget to like, subscribe, and drop your questions in the comment section below. I will also be dropping the link to have access to a full PDF document of this course that clearly breaks down the concept and basics of the course. So I'll be dropping the link in the description of the video. Do so to purchase the course so that you can follow up with our subsequent videos. Thanks for watching and see you in our next video.